naming of alicyclic compounds. Right. Now we have studied about how to write names for alicyclic compounds. So generally here alicyclic compounds means those are cyclic compounds. So here write some examples you see. For example, it is present like this. It is an alicyclic compound. In this alicyclic compound, 1, 2, 3. 3 carbons are present and it is present cyclically. So its name can be written as cyclopropane. It is an example for alicyclic compound. Okay. And you take another example. If it is present like this, total 4 carbons are present. 1, 2, 3, 4. All are single bonds. So we write cyclo. 4 carbons means we write butane. So it is cyclobutane. Cyclobutane is also an alicyclic compound. Okay, right. We take another example. Here total 5 carbons are present. 1, 2, 3, 4, 5. Okay. 5 carbons means its name can be written as cyclopentane. Right. Now we take another example. So here 6 carbons are present. Okay. So 6 carbons means we write cyclohexane. Okay. Cyclohexane it is. And next one. Okay. Here also 6 carbons are present. But here a double bond is present. So we can write its name cyclohexene. Here ene indicate double bond. Okay. Like that we write names for alicyclic compound. So here alicyclic compounds means nothing but cyclic compounds. And here each corner one carbon is present. So 1, 2, 3. 3 carbons means prop. All are single bonds. So it is propane. And here total 4 carbons are present. All are single bonds. So it is butane. 5 carbons, all single bonds pentane. Cyclically present. So we can write cyclopentane. Okay. And in this example, 6 carbons are present. But one double bond is present. Multiple bond is present. So whenever a double bond is present, we can use suffix "ene". So total 6 carbons means X. Double bond is present hexene and it is present cyclically. That's why you can write cyclohexene. Okay. So these are some examples for alicyclic compounds. Okay. Right. These are without side chains. Okay. So without side chains, whenever alicyclic compound is present, we can write their structure like this. Okay. So now we can see within the alicyclic compound if side chain is present. Okay. Now we have to take another type of examples. In this example, side chains are present. Okay. Right. Now I can take an example. You see. Right. Now you see. So here it is a cyclic and it is side chain. Okay. When you see number of carbons in side chain, 1, 2, 3, 4, 5, and within the chain, cyclic chain, 1, 2, 3, 4, 5. Okay. Right. Now you can see in side chain and in cyclic ring, here same number of carbon atoms are present. Okay. In side chain, 5 carbon atoms, and within the ring also 5 carbon atoms are present. Okay. So when writing their IUPAC name, here side chain and ring both are having same number of carbon atoms, then we can write the name like this. Okay. See, in this condition, side chain can be present as substituent, so it is alkyl, and next we can write cycloalkane. Okay. So we can follow this condition. Okay. You see, whenever number of carbons in cyclic ring and number of carbons in side chain both are equal, in that condition we can use alkyl cycloalkane. Okay. So now here if you want to write name for this, total 5 carbons are present, so it is pentyl, and it is cyclic, cyclo, and all are single bonds. 5 carbons means cyclopentane. Okay, we can write like this. Okay. So this condition we can apply whenever in cyclic ring and in side chain same number of carbon atoms are present. Okay. Right. Now we can take another example. So to explain about side chain and this, now I can take like this. Okay. You see, now in cyclic chain, 1, 2, 3, 4, 5. 5 carbons are present. Okay. In side chain, 1, 2, 3. 3 carbons only present. Okay. So in this example, your cyclic ring and side chain both are not having equal number of carbon atoms. Okay. So in these two cases, you see, in cyclic chain, more number of carbon atoms are present. Okay. In this cyclic ring, more number of carbon atoms are present whenever we compare side chain. Okay. In that condition also we can write the name like this, alkyl cycloalkane. We have to follow. Okay. So whenever number of carbon atoms in side chain less than cyclic ring, then we can write the name according to alkyl cycloalkane type. Okay. So So alkyl means substituent. 3 carbons are present. So we write propyl, cyclo, and within that 5 carbons pent, and we write pentane. Okay. So its name is propyl cyclopentane. Okay. Now once you can see these two examples. In these two examples we can follow alkyl cycloalkane. Alkyl cycloalkane. So here remember one thing, that is whenever number of carbon atoms in cyclic ring is equal to number of carbon atoms in side chain, or number of carbon atoms in cyclic ring is greater than number of carbon atoms in side chain. In these two conditions, if you want to write the name, we can follow alkyl cycloalkane. That means your side chain can be taken as substituent. Okay, right. Now we can take another example. It is another example. Okay, see. Now in cyclic ring, 1, 2, 3. 3 carbons are present. In side chain, 1, 2, 3, 4, 5. 5 carbons are present. Okay. So in this example, number of carbon atoms in cyclic ring 3 and in number of carbon atoms in side chain 5. Okay. So your number of carbon atoms are greater than in side chain when compared to cyclic ring. In this condition, it can be present as substituent. That means you write cycloalkyl alkane. This we have to follow. Okay. In that condition, you can follow cycloalkyl alkane. Okay. So it can be taken as substituent. So 3 carbons are present. So we take cyclopropyl. It can be taken as substituent. And in main chain, that is side chain, total 5 carbons are present. 5 carbons we can write pent. All are single bonds means pentane. Okay. It is one rule while writing alicyclic compounds names. Okay. So remember, whenever side chain and cyclic ring, these two are present. So if you want to write its name in cyclic chain or cyclic ring and side chain having same number of carbon atoms, or in cyclic ring having greater than number of carbons when compared to side chain, the name you can follow alkyl cycloalkane. Okay. Instead of that, in cyclic ring less number of carbon atoms are present. In that condition, you can follow cycloalkyl alkane. Okay. You remember this condition. Right. So it is one example. Right. After that, next we can see, we studied some more examples about alicyclic compounds names. Right. Now we take a compound like this. Okay. So if it is present like this, now you see in cyclic ring carbons 1, 2, 3, 4, 5. Okay. In side chain 1, 2, 3. 3 carbons only present. Okay. That means number of carbons are greater than in cyclic ring. Okay. But here the problem is in side chain here a functional group is present. You can see. Okay. So when you can see this in side chain a functional group is present. So whenever a functional group is present, instead of number of carbon atoms counting, the functional group having side chain can be taken as priority. So here functional group is present. We start from here 1, 2, 3. Now it can be taken as substituent. So 3, the total 5 carbons cyclic. So 3 cyclopentyl. Total 3 carbons means prop, and OH group indicate alcohol. So we write 3 cyclopentyl prop 1 whole. Okay, that means whenever functional group is present in side chain, irrespective of number of carbons, we can take this side chain as major. Okay, so that's why you can write 1, 2, 3. On third place it is present, so it is 3 cyclopentyl prop 1 whole. Okay, so this can be considered whenever functional group is present. Okay, so remember, if functional group is present, in that condition we can take like this. Okay, so if functional group is present on side chain, in that condition, instead of taking number of carbon atoms, directly we can take compound with the side chain which contains functional group. For that we can give the priority. Okay, right. Now next example you can see, two cyclic rings are present. Okay, so for example, it is present like this. Okay, two cyclic rings are present. Okay, so here only one carbon is present. So you see 1, 2, 3, 4, and here also same 1, 2, 3, 4. Okay, so 4 carbon cyclic cyclobutyl, and here 4 carbon cyclic cyclobutyl. It is present 2 times. That's why we write dicyclobutyl. First we can write like this, dicyclobutyl, and middle only one carbon is present, so we can write methane. So its name is dicyclobutyl methane. Okay, so whenever cyclic rings repeatedly present, we can use di. Okay, it is also one example while writing naming of alicyclic compound. Okay, right now you can take another example. Okay, now in this example we take like this, you see, double bond CH3 NO2. Okay, so you see within this here cyclic ring, it contains multiple bond. Okay, multiple bond and substituents both are present in that condition. Okay, in an alicyclic compound, multiple bond and substituent both are present in that condition. Lowest number is given to multiple bond. Okay, so if you want to write its name, here multiple bond is present. According to lowest sum rule, we take like this: 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. Okay, remember that whenever in alicyclic ring, multiple bond and substituent both are present, priority we have to given for multiple bond. That means lowest number we have to given for multiple bond. Okay, if you write its name substituent methyl nitro according to alphabetical order. Okay, you write according to alphabetical order. First place methyl group is present, so 1 methyl. Okay, next third place nitro group is present, 3 nitro. Total 6 carbons, cyclo eggs, and see at first place double bond is present, so it is 1 methyl 3 nitro cyclo eggs 1 in. Okay, so this we can apply whenever within the compound, within the cyclic ring, multiple bond and substituent both are present. In the condition, priority is given for multiple bond. Okay, right, now we take another example in alicyclic compound. Okay, we take an alicyclic compound like this. It is 6 carbons, CH3, CH2, CH3. Okay, so it is a alicyclic compound. 6 carbons are present, that is cyclohexane, and now you see 2 substituents are present. So whenever 2 substituents are present, for which substituent we can give the priority. Okay, so remember whenever 2 substituents are present, we can write its name according to alphabetical order. Here CH3 indicate methyl, 2 carbons means ethyl, so it is M and it is starting with E. That's why we give number, lowest number for this: 1, 2, 3, 4, 5, 6. Okay, so on first position ethyl group is present, so we can write 1 ethyl, and third place methyl group is present, 3 methyl cyclo, 6 carbons means eggs, and we write hexane. Okay, so its name 1 ethyl 3 methyl cyclohexane. Okay, so that means on that ring here 2 substituents are present, then we can write its name according to alphabetical order. So according to alphabetical order, which comes first, for that we give the number. Okay, right now you can see another example. It is third one like this, and next fourth one, you see, if it is present like this. Okay, you see again 6 carbons. Okay, on one carbon CH3 is present, and here I take C2H5. Okay, right now you can see again ethyl methyl. Okay, according to this example, first we have to given priority for methyl, after that we given methyl. Okay, so according to this ethyl first, after that methyl we have to take it. Okay, same example here also present, but here 2 methyl groups are present. Okay, so whenever we have to take it like that, in that condition we can follow lowest sum rule. Okay, so according to lowest sum rule, I write like this: 1, 2, 3. Okay, so at first position 2 substituents are present, 1 plus 1. At third position 1 substituent is present. Okay, now your lowest summation rule is 5. Okay, instead of that, if you can take like this: 1, 2, 3. Okay, so in that condition 1, and third place 2 substituents are present, 3 plus 3, it is 7. Okay, so when you see here, we can follow lowest sum rule. Okay, so whenever here we have to given like this substituents are present, if you want to write its name according to lowest summation rule, also we have to follow. Okay, so according to lowest summation rule, here the priority is given for methyl. Okay, at third place ethyl is present, so we write E3 ethyl according to alphabetical order. 1 comma 1 dimethyl, total 6 carbons cyclo, and 6 carbons means eggs, all are single bonds means A. Okay, Here only two different substituents are present. Directly we follow alphabetical order. So which comes first, that we have to given lowest number. Okay, but here three substituents are present. Whenever that substituents are present, compulsory we follow lowest summation rule. Okay, according to lowest summation rule, which it is having lowest sum, according to that we can write the name. But while writing the name, you can see compulsory we can follow alphabetical order. Okay, it is also one example for alicyclic compound. Okay, right. Now some more examples we have to take it. Okay, right. Now I take another example. You see, here I take cyclic ring, but the cyclic ring, it contains unsaturation. Okay, that means double bond is present, and here I take side chain also. Here side chain is also present. Okay, so in that condition, actually in side chain 1 2 3 4 5 carbons only present, and here total 6 carbons are present. Okay, but according to the rule, what you have to tell, if side chain it contains functional group, we can give priority for functional group. Okay, so that's why it is 1 2 3 4 5, and within the ring 1 2 3. Okay, so you see at fifth place this is present, so 5, and within that you see here total it is a cyclo-X, double bond is present. So we write 5 cyclo-X, double bond is present at second place, 2 enyl. Okay, and remaining 5 carbons acid is pentanoic acid. Okay, it is the name. That means whenever within the cyclic ring multiple bond is present and in side chain functional group is present, in the condition priority we have to given for functional group. Okay, according to the total 5 carbons, pentanoic acid, it can be taken as substituent. It is present at fifth place, so we take 5, and within the ring total 6 carbons are present, cyclo-X, and second place double bond is present, 2 enyl. Okay, that's why its name is 5 cyclo-X 2 enyl pentanoic acid. Okay, so this we have to follow whenever a side chain contains functional group. Okay, right. Now I take another example. You see, within this example, I take like this 6 carbons. Okay, it is present like this. Okay, so in this condition, ring contains functional group, side chain also contains functional group. That means two functional groups are present, which you have to take in priority. That means functional group present for ring or functional group present for side chain. Okay, in that condition we can take the priority order. Okay, so here if you have to get two different functional groups are present, then we can compare the two functional groups priority. Here the two functional groups are COOH and OH. Whenever you compare COOH and OH priority is given for COOH. When you compare with OH, the priority is given for COOH. That's why it can be taken as major. That means 3, 4, 5. Here 1, 2, 3, 4, 5, 6. Okay. So now you see here fifth place it is present substituent 5, and it is total cyclo-X. Okay. Cyclo-X, and fourth place OH is present. So we can write like this also. Fourth place OH means 4 hydroxy. Total 6 carbons means cyclohexyl, and outside 5 carbons it is pentanoic acid. It is the name for this alicyclic compound. Okay, when you compare these two, in these two here side chain contains functional group, so directly we can take side chain as major. Okay, but whenever ring and side chain both contains functional group, in that condition we can follow priority order. Okay, if the priority order is present, priority group it is present on side chain, we can take the side chain as major chain, or if the priority group is present on the cyclic ring, then cyclic ring can be taken as major priority. Okay, here COOH OH group, in these two groups COOH you have to generally given priority, that's why it taken as major chain, and it can be taken as substitute here. Okay, right, and next one. Right. Okay, so to explain about this, I take another example. Okay, I take like this. You see, again 6 carbons, double bond O, double bond O. Okay, it is present like this. Okay, or you take like this. Okay, you see. So in this example, cyclic ring contains C double bond O. Side chain also contains C double bond O. That means side chain and cyclic ring, both are contain same functional group. Okay, so whenever same functional group is present, for which you have to given the major. Okay, so in that condition you have to see it is according to number of carbon atoms. Okay, which contains more number of carbon atoms, that you have to taken as major. Okay, that can be taken as parent. Okay, here you see 1 2 3 4 5 carbons, but it contains 6 carbons, so it is major. So 1 2, now we have 1 2 3 4 5. Okay, now it can be taken as substituted, it is present at second place, and total 5 carbons are present. In these 5 carbons, second place C double bond O, that is oxo. Total 5 carbons means pent or pentyl. Okay, or we write 2 oxo pentyl. Now it is cyclohexes. Okay, cyclohexes. First place ketone is present, X1. Okay, we can write like this. That means whenever in cyclic ring and side chain, both are having same functional group, in that condition which contains more number of carbon atoms, that can be taken as major. Okay, so it is also one example. Right. And now you take another example. In this example, a cyclic ring can be attached to benzene. Okay, 5 carbon cyclic ring we have to take, and now it can be attached to benzene ring. Okay, it is benzene. Here cyclic group, whenever it is attached to benzene ring, compulsory cyclic group can be taken as substituent. So we write its name cyclo. 5 carbons means pentyl, and here it is benzene. So its name is cyclopentyl benzene. That means whenever a side chain, whenever a cyclic ring, it is directly attached to benzene ring, in that condition that cyclic ring can be taken as substitute here. Okay, it is one example. Right, now we can see whenever on cyclic ring, functional group and substituent both are present, OH, ET. Here ET indicate it is nothing but C2H5. Okay, in cyclic ring, functional group and substituent both are present. In that condition, compulsory we can give the priority for functional group. So we can take like this: 1 2 3 4 5 6. Okay, second place ethyl group is present, 2 ethyl, total 6 carbons, cyclohexes. And you see at first position OH is present, so we write whole. Okay, so it is 2 ethyl, total 6 carbons means cyclohexes, and first place OH is present, we can take as 1 whole. Okay, so you remember that whenever on cyclic ring, functional group and substituent both are present, in that condition priority is given for functional group. Okay, right. And next example. Right, so whenever on cyclic ring only functional group is present with which contain carbon atoms, then how can you write the names? Now we can see. Okay, so you see, I take an example, CHO. If you want to write it name, okay, so a cyclic ring, it contains total 1 2 3 4 5 carbon atoms, and here one functional group is present. In that functional group, carbon atom is present. So whenever it is present, this number, this carbon is not involved in total number. So if you want to write its name, total 5 carbon means cyclopentane, and CHO indicate carbaldehyde. So its name is cyclopentane carbaldehyde. That means direct functional group can be attached to ring. Within that functional group, carbon atom is present. That will not count in this here. Okay, we write separately about that. So CHO indicate what? Carbaldehyde. Okay, we take another example, similar example. Now here it is present like this, CN. Okay, again 5 carbons. So we write cyclopentane, and here CN indicate nitrile. So its name cyclopentane nitrile. This carbon is not involved here. Okay, we write about that directly. Okay, right. So these are some example for writing names of alicyclic compound. Okay, so what are the examples we discussed? Once we can check. Okay, based on that we can try to write its names.